All right, so ReAct, huh? I always love a good deep dive, and this one seems like it's going to be interesting. You've sent over a ton of research on this, like papers, code, even like thought pieces. It's clear you're really interested in this, and not just what it is, but how it's going to like change AI as we know it.
Well, yeah, it's really fascinating stuff. What's so cool about React is that it kind of mirrors how we think.
Hmm.
That back and forth between thinking and then actually like doing something. It's almost like we're giving these AIs a little taste of the real world.
So instead of just like spitting out answers based on what's already in their, AI brains, they can actually go out and get more info.
Exactly. It's like they've just discovered the internet for the first time and they're realizing just how much information is out there.
Okay, I can see where this is going. So it's like giving someone the keys to a whole library instead of just one encyclopedia.
That's a great way to put it. And because of that, they can tackle way more complex problems, things that need information from all over the place.
Okay, but before we get too far, let's talk about these reasoning traces I keep seeing. It's like the AI leaves a trail of breadcrumbs showing how they arrived at an answer.
Yeah. It's a window into their thought process.
Mhm.
Instead of just a final answer, we see the why behind it, which is huge for building trust,
Mm.
especially as AI starts making bigger decisions.
Right, makes sense. So it's not just about getting the right answer, it's about understanding how the AI got there. And this is important for everything, as AI starts playing a larger role in our lives.
Absolutely. Transparency is key.
Hmm.
That research paper you said about the Hotpot QA dataset, the way React used Wikipedia to answer those multi-hop questions was amazing.
Oh, yeah. That was wild. It was like the AI had its own little research assistant going through Wikipedia, pulling different pages together. It actually felt like problem solving, not just like spitting out facts.
Exactly.
Yeah.
And that's what's so groundbreaking here. It's a fundamental shift. React pushes AI beyond simple questions and answers and into real problem solving.
So no more, here's everything I know, take it or leave it. It's more like, okay, here's how I can figure out what you need.
Precisely.
Okay, I'm starting to see why you're so excited about this. But before we go any further, can you remind me how this is different from what we've already seen? Like, what about that chain of thought prompting? How is React different?
Oh, that's a great question. Something a chain of thought prompting, like, trying to solve a puzzle, but some of the pieces are missing. You can
Hmm.
try to make do, but you never get the full picture.
Right, right.
React, on the other hand, gives the AI access to those missing pieces. It connects them to the outside world.
So it's like giving them the missing pieces and showing them where to find more if they need them.
Exactly. And that's huge. That small shift has massive implications. That Medium article by Ottavio Serra about the Colorado orogeny? That really drove this home for me. The AI was totally stumped until it could access Wikipedia through React.
It's like we're giving AI the ability to learn in real time.
Yeah.
That's amazing. They can use what they know, but they can also say, hold on, let me double check something and go look it up.
Yes. And those reasoning traces we talked about, that they're a key part of this whole process. It's like the AI is thinking out loud, okay, to answer this, I need to do this. And then it's that human-like decision-making that makes React so special.
Okay, so to recap, React uses these reasoning traces to think through problems, and it can interact with external tools like Wikipedia. But where does this actually get used in the real world? One thing I saw in the research was this lang chain thing. What is that?
I is LangChain. LangChain is like the bridge between this cool theory of React and actually building something useful with it.
Okay, but what does that actually look like? Like, how could I use this in my everyday life? Give me an example.
Okay, imagine you need a very specific product. Let's say you want a 3-ounce bottle of bright citrus deodorant, sensitive skin formula, under $50.
Wow, okay, that's pretty specific. I can already see myself spending like an hour online trying to find that.
Exactly. But with React, this becomes super easy. The AI can break down your request, check different websites, compare products based on your criteria. It's like having a personal AI shopping assistant.
So it's not just about finding information, it's about actually getting stuff done. That's
Yeah.
really cool. Like taking a search engine and making it actually understand what you want, not just the keywords you typed.
That's a great way to put it. And here's another mind-blowing thing. The research shows that React can actually outperform traditional methods in certain situations.
Wait, really? So all that think, act, learn stuff is more efficient than just cramming an AI full of data?
Exactly. Because it's not limited by what it was trained on, React can adapt and learn on the fly using real-time information. Now, this is just the tip of the iceberg. We still need to unpack how React stacks up against other approaches, dive deeper into real-world uses, and even address some of its limitations. Because, every innovation has its challenges.
Okay, so you're telling me there are limitations to this like mind-blowingly awesome tech. Don't leave me hanging. What are they?
Well, one thing to keep in mind is that All these reasoning traces and actions, they need some serious computing power. It's not something your average smartphone can handle right now.
So you're saying I can't have my own personal React AI assistant just yet? Bummer.
Not quite yet. But as technology gets better, we'll see more efficient ways to run these things. It's just a matter of time before it's on all our devices.
But actually, there's something else I wanted to mention when it comes to real-world applications. You mentioned text-based games earlier. That's where things get really interesting with React.
Yeah, there was that ALF world thing in the research, right? It sounded kind of like a fantasy novel or something.
It does, doesn't it? But it's actually a virtual world designed to test how well AI can make decisions. So picture this. A simulated house where the AI has to complete tasks like, find a knife, clean it, put it away. Okay, so like a virtual robot butler taking instructions in a digital mansion.
Exactly. And this is where React's ability to reason and act really shines. The AI can't just blindly follow commands. It has to actually understand the environment, figure out the steps, then actually do them.
That sounds incredibly complicated. How does it even begin to process all of that?
Remember those reasoning traces. As the AI explores this virtual world, it leaves behind a trail of thoughts that explain its choices. So you might see something like, to finish this task, I need to find the knife, wash it in the sink, then put it in the drawer. It breaks it down just like we do.
So it's not just doing things randomly, it's thinking through the process, step by step.
And that's what makes it so powerful. The research showed that React was really good at this, even better than AIs trained with way more data.
It's like this whole approach is particularly suited to these tasks that require both thinking and doing, especially in a complex environment.
Exactly. And it ties into something we mentioned earlier, trust. Because we can see the AI's thought process, it's easier to trust that it's making good decisions, not just, stumbling into them.
Right. It's like having a record of the AI's thoughts. That's super important, especially as AI starts making more and more decisions that affect us in the real world.
That's exactly right. And remember that YouTube video by Sam Witteveen we talked about? He made a really interesting point about the size of the language model. Basically, the bigger the model, the better it seems to be at reasoning.
So it's like anything else. Bigger is better.
In a way, yeah.
Yeah.
But it's also about the kind of data it's trained on. Like models trained on a lot of code, they tend to be better at these reasoning tasks because they've learned to think more logically, like programmers.
So it's like a few things working together.
Yeah.
The size of the model, the training data, and then this ReAct approach on top of it all.
Exactly. And remember, this is all still pretty new. As the research continues and these language models get even more sophisticated, we can expect even more impressive results.
This is really cool stuff. But earlier you did mention that ReAct has some limitations. We talked about the computing power needed. But is there anything else we should be aware of?
Yeah, so actually there's one more challenge. And it goes back to those in-context examples we were talking about earlier. We use those to kind of like prime the AI before we give it a task.
Yeah, like giving it a head start.
Right, exactly.
Yeah.
But here's the thing. The effectiveness of this whole ReAct thing, it can really depend on how good those examples are. It's like if you're teaching a student using examples, if the examples are bad or they don't really apply, the student's not going to learn as well.
So even with all this fancy technology, we still need humans in the loop to make sure the AI is getting the right info.
Yeah, pretty much.
Yeah.
At least for now. The research is clear that ReAct isn't like a magic bullet. You don't just set it and forget it. It still needs humans to point it in the right direction. Choose the right tools and data for the job.
So it's more of a collaboration than humans and AI working together. We set the stage and the AI takes it from there.
Exactly. But, there's still so many fascinating details in these sources that we haven't even touched on. Like one thing that really stood out to me was how ReAct could potentially unlock common sense reasoning in AI.
Common sense reasoning. Okay, now you have to explain that one. What does that even mean when we're talking about AI?
Well, think about how much we rely on implicit knowledge to just navigate the world. Like if I asked you, where would you usually find a desk lamp? You'd immediately say, on a desk, duh.
Right. Seems pretty obvious.
Exactly. But for an AI, that connection might not be so clear. It'd have to search through all its data to find every instance of a desk lamp and where it was. But with ReAct, it can tap into that knowledge that's already there and make those common sense connections. It's like we're giving the AI a basic set of rules about how the world works.
So like giving them an understanding that objects need a surface to be on, things usually fall down instead of up, that kind of thing?
Exactly. And with that common sense understanding, ReAct-powered AI could do things like navigate physical spaces so much better. Imagine a robot that can actually tidy up a messy room, picking things up, putting them away. all while understanding basic physics and spatial reasoning.
Right.
We're starting to get into some real sci-fi territory here.
I know, right? It's pretty wild. But let's not get ahead of ourselves. As
Right.
cool as that sounds, we're still in the early days here.
Right. No robot butlers just yet. But it's still incredible to think about the possibilities. This whole idea of common sense reasoning in AI is huge, and it seems like ReAct is a big part of making it happen.
It really does feel like ReAct is more than just a tool. It's like we're using it to understand intelligence itself. Now you're getting it. And that's what makes all this research so fascinating. By studying how ReAct works, we can actually learn about the fundamental principles of reasoning, decision-making, problem-solving. It even touches on these bigger questions about consciousness and what it means to be human.
Wow. Okay. Things just took a philosophical turn. But it makes sense. We're talking about AI that can think, learn, interact with the world. Of course, there are big questions to consider.
Exactly. And that leads us perfectly into your final thought-provoking question. If ReAct lets AI use tools and data from the real world, could it eventually lead to AI actually shaping our physical environments?
You know, that question has been in the back of my mind this whole time. It's exciting, it's a little bit scary, and it definitely feels like something out of a sci-fi movie. It does, doesn't it?
Yeah.
But that's the thing about AI. What seems like science fiction one day can very quickly become our reality. This idea of AI not just understanding our world, but actually shaping it. It's both amazing and something we need to be really thoughtful about.
Yeah.
You know, the ethical implications of all this are huge.
Absolutely. So as we wrap things up here, what should our listeners be taking away from this conversation about ReAct? What should they be thinking about as this technology continues to evolve?
Honestly, I think the most important thing is to stay informed. Keep asking those tough questions and engage in these conversations about the future we're building with AI. This isn't just some abstract technology. It has the potential to reshape how we live in profound ways. And it's up to all of us to make sure it's used for good.
That's a great point. It's a call to action for all of us. This has been an amazing journey into the world of ReAct. From those basic principles to this mind-blowing potential impact. It's definitely something we'll all be keeping an eye on. Thanks for guiding us through all of this. It's been an incredible deep dive.
My pleasure. And remember, the future of AI, it's not predetermined. It's something that we're all actively creating.
That's a wrap on another episode of The Deep Dive. Until next time, keep exploring, keep questioning, and keep diving deep.